Hello everyone, Yashvin here from Exam Help Web. Today we're going to be solving May-June 2019 paper 4 variant 1 of 0620 chemistry. In this video we're going to be solving the first few questions. Starting with question number 1. This question is about the structures of atoms and ions. A. Define the term proton number. So this is the proton number is the number of protons in the nucleus of an atom. Alright. B. B1. Complete the table to show the number of protons, neutrons and electrons present in atoms of magnesium 24 and magnesium 26. Now this shows us that these two are isotopes, meaning that they have different number of neutrons since their mass numbers are different. So the number of protons in magnesium 24 is 12. The number of neutrons is the mass number minus the atomic number, which is 24 minus 12, which is also 12, and the number of electrons is equal to number of protons since this is a neutral atom. So this is also 12. Moving on to the second one, number of protons over here is 12. And since 26 minus 12 is 14, the number of neutrons here is 14. And the number of electrons is equal to the number of protons. Alright, moving on to part 2. What term is used to describe atoms of the same element such as magnesium 24 and magnesium 26? Right, so these are known as isotopes since they have different number of neutrons. Part 3. Explain why the chemical properties of magnesium 24 and magnesium 26 are the same. Alright, so chemical properties always depend on the electrons in the outermost shell, and since both of these isotopes have the same number of electrons in their outer shell, they have the same chemical properties. The only difference is the number of neutrons in their nuclei. So alright. Part C. Complete the table to identify the atoms and ions which have the following numbers of protons, neutrons and electrons. Alright, so here we have to complete the table to show if the particle over here is an atom or an ion and further identifying them. So the number of protons we have, 4. This tells us the atomic number of the atom or ion. And let's check over here. Okay, so as we can see over here, the number of protons and electrons are equal, which means this is a neutral atom. And their atomic number is 4. And since the number of neutrons is 5, we can figure out the mass number of this atom, which is going to be 9. Since we by adding 4 and 5, we get 9. And the atom with the mass number of 9 and atomic number of 4 is beryllium from group 2. And then the next one is an ion. As we can see over here, the number of protons and electrons is not the same. But this ion has a charge of -1 since we have one extra electron. Now we need to figure out the atomic number and also the mass number of this ion. As we can see over here, the atomic number is already given, which is 17, and by adding 17 with 20, we find out that the mass number of this ion is 37. In the periodic table, we can see that the only element with the atomic number is of 17 is the chlorine atom, but we can see that the mass number in the periodic table is given as 35.5. That is because it is an average of isotopes, and this isotope over here has the mass number of 37. So we're going to be writing the chloride ion. Since this has one extra electron, the mass number, which is 37, which is the result of the sum between 17 and 20 and its atomic number of 17. D. State the electronic structure of the following atom and ion. Alright, so we're supposed to be writing the number of electrons in their shells in aluminium, starting with aluminium, which has atomic number 13. So we have 2 electrons in the first shell, followed by 8 in the next, and 3 electrons in the last shell. And sulfide ion, which has 16 electrons, but this since this is a sulfide ion, it is going to be having a total of 18 electrons. So we have 2, 8, and 8. All right. Moving on to question number 2. Z is a covalent substance. In an experiment, a sample of pure solid Z was continually heated for 11 minutes. The graph shows how the temperature of the sample of pure Z changed during the first 9 minutes. Okay, so this is a heating curve, meaning that it shows us how the temperature of a substance changes over a period of time when it is heated. So, I want to first describe what each of the slopes and lines mean. As we can see over here, the temperature is going to be increasing of Z from 0 to 2 minutes, which means from 0 to 2 minutes, solid solid Z is going to be in the form of solid substance. And once we have a horizontal flat line, it means that a change is occurring in the state of substance Z. So since this is solid, the change is from solid to liquid. That is, the solid Z is melting over here. And as we can see over here, after 3 minutes of melting, the slope then continues to go as slanted and not horizontal, which means the solid Z has completely been converted into liquid form at minute 5 and is now a liquid from minute 5 to minute 9. Alright, so we have solid over here and then solid plus liquid, since this is the conversion or melting of Z, and then we have liquid over here. Alright, and the reason for that is the temperature of the substance Z keeps increasing when it is solid, and once it reaches the temperature of its melting point, it is going to be it's not the temperature of the substance is not going to be increasing. Why? Because over here the temperature was used to increase the kinetic energy of the substance, but over here that energy is instead used to break the bonds between covalent substance Z. And once all of those bonds are broken and it has turned to liquid, the substance then continues to gain kinetic energy, since it is no longer needed to break bonds. Alright, so that is how you read this heating curve. A. What is the melting point of pure Z? So as I mentioned earlier, the melting process starts from the horizontal line, and the starting is at 80 degrees Celsius. So this is the melting point of solid Z. Alright, B. The sample of pure Z began to boil at 9 minutes. So 9 minutes is when the graph has no longer continued. It was boiled for 2 minutes. Use this information to sketch on the grid how the temperature of sample of pure Z changed between 9 and 11 minutes. So the question tells us that the substance is boiling for 2 minutes from 9 to 11 minutes, and since this is a change of state, the substance is no longer going to be increasing in temperature. Instead, the energy is going to be used to break the bonds between liquid to move the particles further apart and form gas. So this is going to be another straight line from 9 to 11 minutes, like so. Alright, C. The sample of pure Z was continually heated between 2 minutes and 5 minutes. Okay, explain in terms of attractive forces why there was no increase in the temperature of the sample of pure Z between 2 minutes and 5 minutes. Alright, so this is a question of 2 marks. As we can see over here, between 2 and 5 minutes, this was the substance was melting, and here energy was used to break the bonds between molecules, so the temperature did not increase. And we can write the same thing over here. Okay. D. Describe how the motion of particles of Z changes from 0 to 2 minutes. Alright, so this is a time period where substance Z gains kinetic energy, which means the molecules are going to be moving faster. And since Z is still in the form of solid over here, we know that molecules in solid only vibrate in their fixed positions. So instead of moving or vibrating with the same speed, the speed of the vibration increases. Okay, E. The experiment was repeated using a solid sample of impure Z. Suggest the difference, if any, in the melting point and boiling point of the sample of impure Z compared to sample of pure Z. Okay, so any impurities always lower the melting point and increase the boiling point of a substance. So the melting point gets lowered and boiling point increases. F. A sample of pure Z was allowed to cool from 120 degrees Celsius to 20 degrees Celsius. The total time taken was 8 minutes. Starting from point X, sketch on the grid how the temperature of the sample of pure Z changed between 0 and 8 minutes. From 120 degrees Celsius, it is going to be cool to 20 degrees Celsius. Let's see what state of matter it is at those temperatures. So at 120 degrees Celsius, Z has been melted, the process of melting has been completed, and it is in the form of liquid. And then at 20 degrees Celsius, it is a solid. So we're going to be having a conversion state in our graph. The liquid is going to be converted into solid. So we're going to be having solidifying process over here. So we're supposed to draw a line from as we know that 80 degrees Celsius here is the melting point, and so this is also the temperature solid Z is going to be freezing or solidifying. So the temperature of Z is going to be decreasing up to the point of reaching 80. And now since this is the solidifying point, we're going to be having a straight line since this is the change of state, and now after it has changed completely to solid, the temperature will then continue to decrease up down to 8 minutes. And here we're supposed to be stopping at 8 with the temperature of 20 degrees Celsius. Question number 3. Zinc and copper are elements next to each other in the periodic table. A. Zinc is obtained from zinc blend in a two-step process. In step 1, zinc blend is converted into zinc oxide. In step 2, zinc oxide is converted into zinc in a blast furnace. Outline how each of these steps are done. In your answer, give one chemical equation for each step. Describe how zinc is removed from blast furnace in step 2. Okay, so in step 1, zinc blend, that is zinc sulfide, reacts with oxygen or gets blasted in hot air to produce zinc oxide and sulfur dioxide. So okay, so it is the most important part in this sentence is the word roasted, because the oxygen that we use over here or the air that we use over here is quite hot. So roasted is the main point over here. We need to write that. And the chemical equation goes this way. We have zinc blend or zinc sulfide reacting with oxygen, giving us zinc oxide and sulfur dioxide. And now we need to balance this equation. So we have 4 oxygen atoms over there, but we're going to be balancing this since we need to balance the whole equation. Step 2, zinc oxide is converted into zinc in a blast furnace. Okay, so zinc reacts with coke because carbon is more reactive than zinc, so it displaces or reduces zinc from zinc oxide. Right, so we have our equation as zinc oxide reacting with coke, giving us zinc and carbon monoxide. So the resultant temperature of the furnace is far more than the boiling point of zinc. So we get zinc as vapor, and then we collect it in a condensing tray which is present at the top of the furnace. So basically we distill zinc from the vapor form to liquid form to collect it. Alright. B. Name the alloy formed when zinc is mixed with copper, which is brass. C. Copper is a transition element. It can have variable oxidation states. State 2 other chemical properties of transition elements which make them different from group 1 elements. Okay, so they form colorful compounds. And they also act as catalysts. Okay, moving on to part D, a compound of copper can be used to test for water. 1. State the full name of this compound of copper. So whenever we get the word name, we're supposed to write the whole name and not just the chemical formula of a compound, and that compound is anhydrous copper sulfate. Okay. 2. State the color change that occurs when water is added to this compound of copper. So the color change occurs from white anhydrous copper sulfate to blue hydrous copper sulfate. E. Aqueous potassium iodide reacts with aqueous copper 2 sulfate to produce iodine. Balance the chemical equation for this reaction. Okay, so first off we have the only element which does not have balanced number of atoms on both sides is iodine over here, because on the reactant side it has only one atom. However, on the product side it has 3 atoms. So we could start by writing 3 over here. Yeah, but if we write 3 over here, we get potassium as 3 as well, and we cannot exactly write 1.5 over here. That would completely disbalance all of our equation. So instead of just keeping it 3, we could increase it by number and keep it 4 to keep all of our numbers, to have all of the numbers as whole numbers over here, and then we could balance it over here by writing 2. So this gives us 2 iodine and 2 iodine, which is equal to 4 iodine atoms. So we have equal number of iodine atoms now. But as we can see, we also have 4 potassium atoms. Let's balance it over here. So now we have 4 potassium I 4 potassium atoms as well, and this gives us 2 sulfur atoms and 8 oxygen atoms. When we write 2 over here, we get the same number of atoms of all 3 elements, since copper over here also had 2, and now it has the same number of atoms on the reactant side as well. Part 2. Reduce the charge on the copper ion in copper iodide. As we can see over here, 1 copper atom is enough for 1 iodine atom, which means this copper ion should have a charge enough to cancel the iodide ion, which only has a charge of -1. And to cancel out the charge of -1, we only need +1. That is only one positive charge, so it is 1 plus. 3. In terms of electron transfer, explain why copper is reduced. Well, it gains electrons. Alright. 4. Identify the reducing agent. So reducing agent is the substance which itself gets oxidized or loses electrons. So iodide ion over here is getting converted to iodine atom, so it's losing electrons, and that is why it is the reducing agent. Okay, we're done with this question. Moving on to question number 4. Ethanoic acid is a weak acid and hydrochloric acid is a strong acid. Both ethanoic acid and hydrochloric acid dissociate in aqueous solutions. A. Part 1. Define the term acid. Okay, so an acid is a proton donor. Part 2. The chemical equation shows the changes which occur when strong acid, hydrochloric acid, is added to water. Complete the chemical equation to show the changes which occur when weak acid, ethanoic acid, is added to water. So the ions get separated. We have the negative ion over here and also the positive ion, but since this is a reversible reaction, we're going to be writing the double-headed arrow as well. B. A student does experiments to show that hydrochloric acid is a strong acid and ethanoic acid is a weak acid. The student adds an excess of hydrochloric acid and an excess of ethanoic acid to separate samples of lumps of calcium carbonate. Identify only the identity of the acid is changed between the experiments. All other conditions are kept the same. 1. State 2 observations which would show that hydrochloric acid is a stronger acid than ethanoic acid. So since hydrochloric acid is stronger, it is going to be completing the reaction faster, which means we're going to be getting the carbon dioxide bubble. Since this is a carbonate salt, we'll be having more bubbles or faster bubbles, and this will also get dissolved, or the reaction would be completed faster. So one of the observations is that solid dissolves faster, and we get the bubbles stop forming quicker as well, since the reaction gets completed well before the other one. So fizzing stops earlier. Since the reaction gets completed faster, the bubbles formation also stops earlier. 2. The student uses the same size container and checks that the pressure is the same for each experiment. State 3 other conditions which might be kept the same to ensure fair testing. So we need to write down all of the points which we keep same or which we change whenever we're testing rate of reactions. So we have same surface area, And here we have the solid as calcium carbonate, so we need surface area of calcium carbonate to be equal. And temperature, and also the concentration of acids. C. Hydrochloric acid produces salts called chlorides. Magnesium carbonate reacts with hydrochloric acid to produce magnesium chloride. A student uses 50 cm cube of 2 mole per dm cube hydrochloric acid in an experiment to produce magnesium chloride. Calculate the mass in grams of magnesium carbonate needed to react exactly with 50 cm cube of 2 mole per dm cube hydrochloric acid using the following steps. Okay, so first off, we're supposed to be calculating the number of moles of hydrochloric acid in these volume and concentration. Now let's convert 50 centimeter cube to dm cube to multiply it with this, so we get the same units. Dividing it by 1000 gives us 0.05 dm cube. Right, so we get the volume as 0.05 dm cube, and as we know, the formula for calculating moles is concentration into volume when given these values. So we're going to be multiplying this value 0.05 with the concentration, that is 2, and we get the answer as 0.1 mole. Okay, determine the number of moles of magnesium carbonate which would react with 50 centimeter cube of 2 mole per dm cube. As we can see over here, we have the um, ratio set as 1 mole of magnesium carbonate reacts with 2 moles of hydrochloric acid. That is exactly 2 is exactly the double the amount of 1 mole. So in this situation as well, we're going to be having half the amount of magnesium carbonate as hydrochloric acid. So we had 0.1 moles of hydrochloric acid over here. Dividing it by 2 or making it half gives us 0.05 moles. This is a set ratio, and this is how we can deduce the number of moles when we have to use only the equation. Calculate the relative formula mass of magnesium carbonate. So magnesium has a mass number of 24, and we're going to be adding all of the other compounds as well. So carbon is 12 and oxygen has mass number 16, and since we have 3 atoms of oxygen over here, we're going to be multiplying it with 3, and the sum of all of this okay, so the sum of all of this is 84, so we get the MR as 84. Now calculate the mass of magnesium carbonate needed to react with 50 centimeter cube of 2 mole per dm cube of hydrochloric acid. So we have the MR and also the moles. So calculating the mass, we need to multiply these value moles with MR. So we have 0.05 multiplied with 84, which gives us the mass as 4.2 grams. And here we have our answer. D. A student prepares crystals of magnesium chloride by adding an excess of magnesium carbonate to 50 centimeter cube of 2 mole per dm cube hydrochloric acid. The student filters the mixture and rinses the residue. 1. Why does the student add an excess of magnesium carbonate? So that all of the acid is used up. We don't want any remaining acid when we start forming the crystals. Okay. Part 2. Why does the student rinse the residue? Well, to get all of the magnesium chloride salt so that none of it remains behind. This will make all of the calculations in our stoichiometry problems over here as close to accurate as possible. 3. Describe how the student would obtain pure crystals of magnesium chloride from the filtrate. Okay, so first, and then the second point is let it cool. And thirdly, filter, wash, and dry it. Okay. E. Silver chloride is insoluble. It can be made by precipitation reaction between aqueous barium chloride and a suitable aqueous silver salt. 1. What is meant by the term precipitate? Well, it is a solid which forms when two solutions react. Okay. 2. Name a suitable silver salt to prepare silver chloride. Complete the chemical equation to show the formation of insoluble silver chloride from aqueous barium chloride to and the silver salt you have named. Okay, so I'm going to be using silver nitrate. Okay, so we have silver nitrate over here giving us silver chloride and also barium nitrate. And since barium has a charge of 2 plus, we're going to be having two nitrate ions because nitrate ion has a charge of -1 only. So we need two of these negative ions to cancel out the charge of one barium ion because it is 2 plus. So we had two chloride two chlorine atoms over here. Let's equate it on this side as well. See, so we would have two chlorine atoms. So now we have this is the reactant side. So we have two silver atoms over here, but let's balance it on the reactant side. And now I think the number of nitrogen and oxygen are also balanced. Yes, 2 nitrogen, 6 oxygen, same over here. 6 oxygen, 2 nitrogen. Yeah, and the number of chlorine is also balanced. Okay, question number 5. Structures of 5 alkenes A, B, C, D, and E are shown. A. What is the general formula of alkenes? So this is CnH2n. B. What is the molecular formula of alkene D? Alright, so molecular formula is the formula we have where we have the formula showing all of the total number of atoms of all of the elements. So here we have 5, 2, 3, 4, 5 carbon atoms. So we have C5 and H10. I could have counted the number of hydrogen as well, but since we can see that this is an alkene, we can simply just apply this formula and figure out the number of hydrogen, which is double the number of carbon in an alkene. C. Predict which alkene A, B, C, D, or E has the highest boiling point. Alright, so highest boiling point means the compound requiring the most energy to break the bonds, and that is going to be E since this has the largest carbon chain. So that is E. Alright. Part D, which alkene A, B, C, D, or E diffuses most quickly? Explain your answer. Alright. So in diffusion, we need to see which of these alkenes is going to be um, moving with the most ease. That is, which of these is going to be the lightest, and that is A, because it has the lowest MR, or the lowest weight. E. A student added aqueous bromine to alkene C. Describe the color change seen and draw the structure of the product. Show all of the atoms and all of the bonds. Okay, so once bromine reacts, this bond opens up, and the since this compound reacts with bromine itself no longer remain. So we're going to be the color is going to be changing from brown to colorless, since bromine has the color brown, and this compound is going to be colorless, which forms after the reaction. Alright, so the structure, the only difference over here is that the double bonds open up. So we have four carbon atoms over here, and all of the bonds are going to be opening up. We'd be having two bromine atoms, and the rest of them are going to be hydrogen. That's it. F. Two different alcohols can be produced from alkene B by an addition reaction. 1. Draw the structure of the two alcohols. Show all of the atoms and all of the bonds. Okay, so when an alcohol forms from this alkene, the double bond is going to be opening up. So we have three carbon backbone atoms over here. Alright, so in the first structure, I'm going to be drawing the alcohol group with the first carbon. And its isomer, that is the second structure, would be having the alcohol group in the second carbon, bonded with the second carbon. So the position of the group changes, but the rest of the structure remains the same. 2. State the reagent and conditions needed to produce an alcohol from alkene B. So we have 3 marks over here. We need to mention 3 details. The reagent is steam, and the conditions used are, well, a temperature of 300 degrees Celsius and a pressure of 60 atmosphere and a catalyst of phosphoric acid. Catalyst, okay, so I'm going to be writing catalyst first. And we can write either of the temperature or pressure because catalyst is important. I'm going to be writing the pressure. (300 atmospheres). Okay. G. Alkene C can be converted into a polymer. 1. What type of polymerization occurs? Well, since this is an alkene, it is going to undergo addition polymerization. 2. Suggest the name of the polymer formed. Well, it forms poly, and since we have this is butene, right? So this is going to be polybutene, but we are also supposed to be mentioning the change of double bond, and since this double bond is with the first carbon atom, we're going to be writing this as but1ene, which tells us that the monomer had the double bond with first carbon atom. Complete the chemical equation to show this polymerization. Alright, so this is going to be pretty much the same. The only difference is going to be the opening up of the bond. So we have the same number of carbon over here, C2, H5, as we had earlier in the reactant side. The number of hydrogen also remains the same. We're going to write an N over here. State the empirical formula of the polymer formed. So empirical formula means the simplest formula. So we have CH2 since this has formed from CH2. Alright, so we are done with this paper. Thank you for watching.